Hey guys, I hope you're having a lovely day. In this video, we'll be going over how to install and use Docker, along with an introduction to some of the fundamentals of it too. We'll also set up some applications you may find useful in this, as to get an understanding of it a bit better. To start with, the prerequisites. It's nothing too complex, but to go through them, obviously you'll need a Linux distribution installed on a system of your choice. For this tutorial, I'll be using Arch Linux, but almost everything should be the same across all distributions once Docker is installed. A basic understanding of Linux and the terminal. It doesn't need to be a lot of experience, but enough to know how to use it. And lastly, a text editor of your choice, like Vim, Nano, or Visual Studio Code. As long as you can open a text file and edit, we're good. If you don't want an introduction to what Docker is, you can skip to this timestamp here. If you do though, then stick around. We'll start with the first and major question. What even is Docker? Docker is a container engine that allows you to build, test, and deploy applications quickly in a consistent format. It simplifies everything by including system libraries, tools, code, and runtime into a container that is able to be run through Docker. By doing this, it removes any dependency of the system other than, can it run Docker? The structure of a container is a bit more fun though, so let's explain. First, we have an image, which is a read-only template with instructions on how to create a Docker container. Images can be based on another image, such as a distribution of Linux, but with additional components on top. And an example might be that an image is based on Arch Linux, but it will also install Nginx in your application, as well as any configuration to make the application run. These are, as we stated, templates. No changes are made directly to the images themselves. However, any changes happen inside the container. The container is a runnable instance of an image. It is defined by an image as well as any configuration options we provide. The container is read-write, meaning changes can be done to the image inside the container if they are required, such as changing default configuration variables for an application. Volumes provide files or directories that reside on the host to the container. For instance, if we wanted to have a photo and video backup solution like image, you may want your library to be outside of the container on the host directly. Another instance is pointing a configuration file from the host to the configuration file of an application in the container, making it easier to edit and make changes. Do note the permissions come into play here, typically from the container, as it can cause issues. We'll go over some of it in this guide. Networks are what allow containers to interface with the host, and it achieves this by creating a virtual network interface. By default, it is isolated from the host, so the container has zero awareness about the kind of network it's on. There are other kinds of modes which change how the container interfaces with the host, which we'll go over later as well. The installation of Docker varies from distribution to distribution. However, I will be primarily covering Arch Linux in this tutorial here. I'll link my post in the description, which goes over some other distributions. In the case of Arch Linux, Docker is already in the repositories, so it's as simple as running one command. In this case, it'll be sudo pacman-s docker and docker compose. Just chuck your password in. In this case, I've already installed it before, but you'll have a few more packages to install, but you hit yes. And now it's installed. In order to start it, then you'll just go ahead and just use another command. It'll be sudo systemctl. In this case, I'll just go enable now docker.service. And the whole point of that is to basically make it so it starts on boot and for it to start right now, essentially. Now Docker is installed and we are able to start it. To ensure it's working correctly, we can start a test container, which will create and start a Docker container used to ensure it is working correctly. In our terminal here, we will run sudo docker run hello world. And for you, it'll probably download. In my case, I've already got it downloaded, but it will download and then this will come out. And as it says, basically the client, which is what we just used here, contacted the daemon pulled the image, created a container with the image, and then it spat this text out. And just like that, if you got an output like this, then Docker's installed and running correctly. So we know Docker works all good, but we'd like to run something that can be a little bit more useful, wouldn't we? Well, we can. For the first container, we will use Uptime Kuma, an application that lets you display uptime and downtime of any services you host. Similar to running the hello world container, we will run sudo docker run -d restart equals always -p 3201 3201 -v uptime Kuma. It'll be colon app data and obviously the name will be Uptime Kuma, and then Lewis Lab Uptime Kuma -1. And I'll give you a string of letters. If it has, then that means that the container has been started. Obviously, the image would be downloaded first. In my case, I already have it. And then once the image is downloaded, it will then create the container and give you the string. So now we want to be able to access it. So to access it, it'll be hosted off your IP address of your computer. So to get that, if you already don't know it, you can just go hostname -i. That'll give you an address here, as you can see. And just like that, we'll be able to go into a browser. We can go 192.168.0.125, put a colon 3001. And just like that, Uptime Kuma is running and it's fine. So the question is though, the command we just ran, what is it? Like, what do we just do? So the first part would obviously be docker run. That's obviously, create a container based on an image. -mean means detach. So basically, rather than it running in the terminal, it will run in the background on its own. Restart always means that if it ever crashed or something or other, it will always try to restart, so it doesn't ever fail. And then you have -p 3001, 3301. Basically, this is the port number that it's going to be going off of the system and also the container. In this case, the left side here is the host. So that's what we'll use to access on this end here. And the right side is the container. So that's obviously going to be whatever port that the application you're running, so in this case, Uptime Kuma is using. So it's using 3001 here. Then you have the volume, which is obviously Uptime Kuma app/data. Basically, in this root folder we're in, it's going to create this folder here. It's going to be called Uptime Kuma. And then it's going to redirect anything in this folder into here, and also vice versa. So if the container adds anything here, it'll end up there. Also the name, just basically the name that you can identify it with when you're using the run command. And then the image that you're using. Then the one on the end means the version. So in this case, it means version 1. Now you might want to know some commands to actually manage the containers that you're running. So in this case, we'll be able to do one such as like stop. So we go sudo docker stop, it'll be Uptime Kuma. And then once it finishes, it'll just take a while. There you go. When it gives you an output of the container name, that means that it's successful. So if you hit refresh, as you can see, it's down. It's not running anymore. But then you might want to start it back up. So then you'll just go start. And just like that, it's running again. So you can hit refresh, and it's obviously back. And then you can do the same thing as those two, but with restart. So if you just hit restart, it'll just restart the container. No, nothing special there. They just command to start, stop, or whatever else the container. And then in this case, say if we want to go ahead and have a look at the port numbers of the containers and see what ports they're using, you can use port and then the container name, so Uptime Kuma. As you can see here, it's telling you that port 3001 on the container end is going to any address available on the system at 3001 as well. So in this case, that's our main address here. And it can also be localhost. If so, you could also do like 127.0.0.1, 3001. It should behave the same, as you can see. And then you might want to do something like docker exec. So docker exec, basically what this will do is it will create, well, it won't create, sorry. It'll allow you to execute a command inside the container. In this case, we might want to use bash. So you might want to have like a terminal in there. And just like that, we have access in the container now. So if we go like IP address show as an example, obviously that command doesn't exist, but the big commands that you can run, and it will happily run them without problem. As you can see here, hostname-i gives us the address of what the container sees. And then in this case, you can also just hit exit. You can run whatever you want. The IT means that it's interactive. So if there is a shell, like this case here, bash, it will allow you to type over commands you want in here without a problem. And then if you wanted to go ahead and say remove the container, if you didn't want it running anymore, or you just didn't want to have it at all, obviously you got to stop the container first, and then you'll just use RM. So change stop for RM, and the container has been successfully deleted. So that's the simplest form of running Docker containers on a PC. The only issue is if you want to change anything like a port number or a volume or anything like that, you have to go ahead, remove the container, and then set it back up. So basically you have to constantly delete, set a container up, delete, set a container up if you want to change anything and test stuff out. So what if there was another way of doing it? Well, there is. We have Docker Compose for that. Docker Compose is a way to define multiple containers in a stack, also a group of containers, much easier, but also allows you to define arguments that are easily interchangeable as well. Much of the syntax carries over from regular Docker commands, so the usage is pretty simple. When using Docker, I recommend using Compose where you can, just so you can modify things easier, as opposed to having to constantly remove them and then set them back up again. So just like the first container, we will set up Uptime Kuma again, but using Docker Compose this time, just to give you an idea of comparing this to, say, the Compose file. So first thing you got to do is you make a directory for the Compose file to live in. In my case, I'm just going to go make dir and then services, and then cd into that. So services. And in this case, I will make a folder for each different service or application. So Uptime Kuma is going to have its own folder. I'll just go make dir and then Uptime Kuma and then cd into that as well. And then here you should be able to go and run this one command. What it will do is it'll download the compose file from the repos of Uptime Kuma. You can go find it yourself. It'll be in the guide if you want to download it. However, in my case, I'm just going to copy and paste the command because it's a lot easier. There we go, it's downloaded. And then we want to open it and have a look what's in there. So we go docker compose.yml. As you can see, it's very simple looking. It looks a bit more complex than the other command that we ran, the run command. But I'm going to show you that it's practically the same thing. There's not much different. So in this case, we have obviously the run command here. We have docker compose here. Services will explain just what containers are going to be ran inside this compose file. And obviously the main container is going to be Uptime Kuma. Then you have the image, which is pretty much the same as it is over here. And then you have the container name, which is also the same as over here. Not much changes there. Then you have the volume. And as you can see, the volume name is slightly different. It's not by much, but otherwise it's going to go in the same place. So it's still a volume regardless. And then you have the port number. As you can see here, it also explains what the port numbers are actually meant to be. So I said, this is the host and this is the container, host, container. And then restart always is the same. It's not much different. So say in this case, we want to run Uptime Kuma on a different port. Well, I'm going to go ahead and edit this one just over here and we'll make it 5. We'll make it 3005 and you'll be able to say that. Go W and Q, and then to start it up, all you've got to do is just go sudo docker compose up -d, obviously -d for meaning detach. As you can see, it runs in the background. Hit enter, put your password in if you have to, and then just like that, it's running. So you should be able to also go to the 192.168.0.125.3005, and as you can see, the port number has been changed and it started up just fine. And the commands for are still very similar to how just the docker run command works, but it's a little bit different. So in this case, we'll just go down. So if you want to stop it, just go down and it'll stop everything. And then once it has stopped, obviously up -d will still bring it back up. But if you want to restart it, you can also issue a restart and that'll restart just fine. It will do basically the down and the up together. And that's pretty much the gist of the commands. It's basically going to function the same. It'll be slightly different. So say if you wanted to go, it'd be -v. I believe I'll go down -v. It'll remove any volumes and whatnot. So similar if you were to go RM with the container, it will remove obviously the container and any volumes you had. In this case, we don't really want that. We want to keep them. And another thing you might want to look at is what's actually in the volumes themselves. So obviously in our case, if I go back to the compose file, we have the container here, which is Uptime Kuma data. So if I were to go quit and then go as -l, Uptime Kuma data, as you can see, there's a bunch of files here that Uptime Kuma has made. And these all are being used by the container itself. The container itself will see these files in the directory that was defined. So that would have been /app/data. And to prove that, we can go and go sudo docker exec it. If we were to go ls-l, it'd be, what was it, app data. There you go, it's the exact same files. There is no difference at all. Say for migration purposes, if you wanted to transfer this container from one system to another or one directory to another, all you got to do is just bring this folder with you and just point to the same folder. You can rename it as well, as long as you change it in the compose file as well. And then just start it back up and it'll be exactly as you left it essentially. In that example there with Uptime Kuma, as you saw, there's only one container. That was Uptime Kuma itself. A lot of programs, applications that you'll run through Docker have more than one. So in that case, we will still use compose because compose allows you to define more than one, start and stop them all at different points if you have to. So the next one we will run is image. It's a self-hosted photo and backup solution. Think of it like Google Photos, but self-hosted, and that's pretty much it. Personally, I've been using it for more than 3 years. I've donated them as well to show the support. And I think if anyone needs to learn a program first to install, I think image is probably a really good one to start off with. So, similar to Uptime Kuma, we will go make a directory in the services folder. I'll call it image. Obviously, cd into the same folder as well. And we will download the Docker Compose file and the environment file. I'll have them in the guide, but you can also find them on Image's website on GitHub. It's all there anyway. But in this case, I'll just copy and paste the commands again. That will be the compose file. And then this will be the environment file. So then, in this case, we'll also open up Docker Compose because it's all the same file pretty much. And as you can see here, there is a bit more going on than what you would expect normally. So we can go through it a bit because there are things that remain the same. So also you have services, that's where the containers are going to run specifically. And then you have obviously image, that's the server itself, the container name. Then you have the image, the volumes. As you can see here, these are slightly different. So you have the upload location. They'll be defined in that second file we download, so the environment file. Just so you have to dig in here or anything so much. You just go in that little file and edit it out. And this basically will bring over all the local timings of the system, and it'll be in place, in the same place as the system in the container. It's as read only, so the container can't modify it because you don't really want that. Also, you have an environment file. It's pointing to the environment file that we downloaded just before. It's just so it can pull values for, say, the upload location, or even values such as the passwords and the usernames, whatever else. So that's what that's there for. And then obviously you have depends on. Depends on basically means that in order for this service to work, these two need to work as well. So if for some reason these two weren't running correctly, or something or rather, the server would not start. It would fail to start. And obviously restart always the same. And then you have a health check. Some applications may have a health check. Basically, what the whole idea is to make sure that if the application is running correctly, this will give a positive reading. If it does not run correctly, it'll give a negative reading. So you know that, yeah, it might be running, but there is something wrong with it. An example with that here will be Redis. This has obviously the ping command. Basically, if it pings, it gets successful, it'll give off a reading of 0, saying it succeeded. If not, then it will say exit 1, which means there is something wrong. And then we have, say, here's an example with the image machine learning container. Obviously, we have the container itself and whatever else. And then you have hardware acceleration. This I won't cover too much right now. I'll cover it a little bit later. But hardware acceleration, you can pass a GPU through to a container and it'll happily use that. In this circumstance, I'll probably be using an NVIDIA GPU because that's what I've got in the system. And then otherwise, the container is mainly the same. And then here, mainly the same, apart from the health check, which we already went over. And then mainly the same here as well. You obviously have a few more environment values or variables and whatnot. So obviously you have the password, the username, the database name, that's all there. And then you have, say, here, which is your database data location. So that's where your database is going to live when it comes to just storing files, hashing them, and whatever else, which that's probably too far over your head, it's too far over mine sometimes, and that's all good. The one change we will make to this file though will be to add a volume for Redis, just because if you were to say migrate your image container here elsewhere, it will not actually carry over. It won't work because these two are required to keep like all the data and whatnot in line. It'll just come with a bunch of like blank images as you scroll through. So if you want to add a volume as an example, I'll add it just below the image because at least to me it makes a bit more sense to. We'll go volumes, colon, and then it'll be under, we'll make it a variable in the environment file, like all these. So we will go, it'll be, what is it? Have to be the $sign in that, db redis location. And then you want to put the curly brace there, colon, data. And now whatever Redis puts out will end up in this location here, which means that you can go ahead and copy these out without a problem, and it'll migrate just fine. In this case, we'll go write and save. And then we might want to have a look at the environment file to see what is defined in Docker, where it's going to reflect in there. So vim.env, because that's what it's called. As you can see here, it's pretty simple. This is just telling you that within the same file, it's going to get a library, same file going to Postgres, and then that's setting a time zone, which I would recommend, but I just couldn't be too bothered. I'm too lazy to do that. But we want to add the Redis one. So if we were to go db redis location, and then go equals /redis. So now we will have the Redis container put all its data in this folder just here. Just like that. Don't need to change anything. All you got to do is just back out of it. And now we know that it's all set up. You can just go sudo docker compose up-d. Put your password in again. Just like that. It'll pull all the images, as you can see, because I don't have it this time. But the main reason was because the Australian internet is terrible. But once it's all downloaded, I will come back and then we'll have a look at it. And just like that, image is now running. So, the one thing I didn't get to look at was what port image is running on, even though I know off the top of my head, just for your convenience, I'm going to have a look at it. You see 2283. But you may notice that only the server has a port. None of these have a port. So you're probably thinking, why? Well, the main thing is, these don't really need to talk to anything outside of the stack itself. All of these will communicate with the server and they'll communicate back. But there's no point of having a port taken up on the system for something that you just don't need to use. It's only going to be used in image. It's only going to be used by the server. So there's just not a port outside. Because the thing is, the stack still has its own little network. And this is reflective of this, because that's the internal port. These all have their own internal ports as well. So that's how they all talk to each other. But we'll go over that in a second, as you can see here. So we learned very quickly that obviously these are container names, whatever else. We also have the network. The network name is image_default. So if you go sudo docker network inspect, and then go image default, and then put the password in again for the millionth time, you'll see here that each different container has its own IP address. So in essence, it's going to be able to say if the server wants to talk to Redis or Postgres or the machine learning container, it will define this address with a port and it'll be able to access it just fine. And that's how part of the isolation works. Much like a normal gateway does, say, for your internet, this is the main one that everything will come in and out of, like your home internet does, but then they'll all talk behind these ports here in their own little isolation. So it's a form of security, essentially. It's can't go too wrong. But anyway, we will go ahead and go 192.168.0.125. 2283, like we just discussed earlier. And just like that, we have image installed and it's ready to go, apart from signing up obviously, but you know what to do there. When it comes to networking in Docker, there are different kinds of modes that you can use. The default one is bridge. So that's the one that, as I showed you earlier, where you have the gateway address, and then you have all the separate addresses for all the containers. That's the one that has the isolation as well. But then you may have one like host. Host ends up basically passing through the container to the host network directly. There's no isolation, which means the container's IP address is also the host's IP address. There's a couple others as well, but you're not going to use them as much as those two options on their own. And then talking about the permissions and whatnot, or volumes, basically, obviously, a container is still basically a running system. They all have their own different users and whatnot, much like a normal Linux system does. So if we were to go ahead and have a look here, say if we were to have a look at, I would say, Uptime Kumar as an example. Actually, no, we'll have a look at image, because image, I think, provides a better example. So obviously here we'll go, there's just L, put the password in. As you can see, the folders are here, but as you can see, they're owned by root and whatever 999 is. But basically, Docker runs as root for pretty much everything. There is a rootless mode in Docker, but it doesn't work as well. You're better off using something like Podman, which I plan to cover in a future video. But for now, we're sticking with Docker. So any normal folder that, just say the server's going to use as an example, it'll be root. But then you have something like Postgres or Redis where they have their own users. So that would probably be the Postgres user or the Redis user. And basically they will carry over the permissions from the container onto the host, as you can see in this example here. And if you were to go ahead and try, say, go into them without root, so if I get rid of sudo, that'll work fine, but the other ones will spectacularly fail. And there you go. But if I run that as sudo though, it'll run fine. But as you can see, it's all owned by that one user, which that user in the container is very likely Postgres. So now that we've covered the AMD and Intel side of things, let's cover the NVIDIA side. The NVIDIA side has a little bit more configuration, but it's still nothing too complex. So the first thing we'll have to install is the NVIDIA Container Toolkit. Now this varies from distribution to distribution. In the case of Arch Linux, it's already in the repo, so I can install it from there. However, I would advise you to have a look at NVIDIA's site regarding it, which I'll have in the guide as well, in the same page as this, and then go from there. So in the case of Arch Linux, it'll be sudo pacman-s NVIDIA Container Toolkit, which I already have installed, but might as well install it again. And then we'll have to run a command. It'll be sudo NVIDIA ctk, obviously runtime, configure, runtime equals docker. Obviously it's going to say that the file doesn't exist. It's written a file to that directory, and that we have to restart the daemon, which is all good. So sudo systemctl restart docker. That'll take a little bit to get going, but it will get there eventually. My fence will probably kick up, to be honest. Come on, you won't. There we go. And then we'll be able to add the part in the compose file to allow the GPU to be used. So it's slightly different compared to the other one in the fact that there's a lot more lines, but it's just as easy. So it'll be deploy, resources, reservations, and then devices, be dash driver, NVIDIA, count all capabilities. It'll be in brackets GPU. Basically, it's saying to grab the GPU, obviously it's an NVIDIA GPU, grab all of them. So if you have more than one, it'll use all of them. And then the capabilities GPU basically means use the compute, use the encoders or whatever else. It unlocks everything for the container. Just because don't really have to be too specific. I might use all of it anyway, whether it's like detection or something like that in FreeGate as well. But in this case, we're just doing encoding. So just hit save, and then you should be able to start back up. And then we'll give that a bit to reload. And we should be able to go have a look now. So if we hit refresh, as you can see, GTX at 70, 13%, it's being used. So obviously pass it through just fine. As you can see, camera is working. That's going through the GTX 1070. Just like that, we've passed an NVIDIA GPU to a Docker container. So with Docker specifically, you've got to be careful with where you place things and what you have them as, because depending on the permissions of the container, you may not be able to properly access them, whether they become root or whether they become part of like the Postgres user. And that primarily concludes this tutorial on Docker. It's not meant to be anything too in-depth. It's more meant to be a bit of a jump start. So if you already know a little bit about it, but you're not 100% confident, there you go. If you enjoyed it, cool. Do what you want. And I'll see you guys next time.